Okay, so we'll start first with the slide. Talk about the third part of the major project. So I'm already actually explained the outline of the report during the lecture, and I think you got the video, right? Yeah. Yes. So today I shouldn't have it that way. Just give me 1 second. Stop doing that. Okay. So, and the third part of the major project session, we're going to talk about the other machining processes. In the second one, we talked about the turning process for the gear parts. And of course, you remember that the gear part itself should be cut it. We should cut the teeth for the gears on the part, and this should be done on the milling machine. The second part of the process is going to be the main body and how we are going to do machining for it. Now, as you can see from the photo of the main body here, that this part cannot be rotated on the milling machine. It's big solid part and non-symmetrical, so it cannot be rotated on machine. So definitely we're going to do that part on milling machine and honing machine or a drilling machine, but not going to be on turning machine. So my first question is going to be, we need to clamp the part. So we have different ways to clamp the part. For example, using the devices, we can use the special devices. Actually, we can hold multiple parts at the same time, especially if we're going to do the work on the what we call the milling stations or turning milling stations, which can do a multiple part machining at the same time by using the special holding device. So for example, you can see here we can hold up to 6 parts at the same time, and the machine will be done for every single part individually. We can have a special designed clamps, and this will be in case if I get to have a special part which cannot be held with the common clamps available for us. Okay, now these are more different shapes of the clamps, as you can see here, holding different geometries during the machining operation. Now, the most important thing for us to increase the productivity, which means reducing the machining time, we need to use a holding device that can be open and closed in faster rate. And that's what we're actually having for this one. Okay, so simply just unscrew, remove the part, and screw another one. Even if we're going to have machining center, we need to load and unload the parts on the what they call the pallet at faster rate. Less machining time, that's mean we're going to have less cost for the parts. Now, this is a video for the work holding examples. I don't know why I can't have the... So you can see that we have 2 pallets, and each pallet is actually carrying something about 12 parts, and the machine will be done seamlessly on all the parts at the same time. Now, actually, this is 2 on each side times 4, that's 8. So we have machining 16 parts at the same time. And this, of course, is going to reduce the time for the machining. I don't know why I don't have the voice for that. Drilling, we can do the threading. Okay, so that machine, once again, is called the machining center. Sometimes it's going to be a milling drilling machining center, sometimes it's going to be a milling turning machining center where the parts can be machined all at the same time. This part actually is a car carburetor, and that's for the old models before we have fuel injection. So this will be the shape of the CNC machining center, where we're going to feed the pallets inside, and this can be usually done by using the something like that, which we call the material handling system. We have main system and we have secondary system. Usually the main system is going to be on this line, and here we're going to have the secondary system when we're going to have the buffering for the pallet before we're going to feed it to the machine. More example is the machining pelting system, as you can see here, which can be going in rotation or it can be working as a conveyor belt. Each one is going to have multiple parts which are going to be fed to the machine continuously. And when they're going to be finished, the worker outside is going to unload the machine part and load the pallet with a new parts on machine one. And this will be very useful for the case of the time reduction for the machining. Okay, so this is another video for the six pallet station. Sorry for the voice, but I'll try to find something about it. I'll try to upload all the videos for you on Teams.
System make it easy for your help with a low-risk option for job shops looking to automate the process. Like other high-productivity machines from Haas, EC400 Help has a number of unique features that make it a perfect fit for both high-production environments and job shops looking to expand their capabilities. Unique features. A 7-pocket side-mount tool changer, automatic chip repair, 300 psi fuel coolant, and advanced fuel management functions make the EC400 Power an extremely capable resource for any production shop. Simple installation. A powerful unit is assembled at the factory and shipped in one piece. At installation, the EC400 installs just like a standalone counterpart. The power unit is aligned using a metal technique supplied with the machine. Fine adjustments take just a few hours. Intuitive pallet scheduling. The EC400 pallet unit programs just like any other Haas machine using industry standard G code. 6 pallets in the pallet unit are scheduled using the versatile pallet scheduler scheme fed to the current command pages for control. Here, the operator will assign a program to each pallet, schedule jobs, and set a parallel to the operator can move the power on the load station back to the storage rack, simply by powering the power number.
Okay, so the one inside is the primary handling material system, and the one outside, which holding the pallet, we call the secondary one. Okay, I'm not going to continue that, but it's very important thing to know that, okay, now this machining center, that's a multi-million-dollar machine. So you are going to put it as an alternative machining process. It's not going to be the main one. Why? We have a workshop. We have a CNC milling machine, and we're using it for a different job. In case if I'm going to be specialized in making this model of the pump, then we have to go for a specialized machine like this one, which can do the massive production. But if this project is going to be a shop job, that's been, okay, now we had a customer and he said, okay, I would like you to make 1,000 pieces of that. So you are a contractor. So as a contractor, you will accept the job, and he will give you standards and specification for the pump, and you will start to do the work. You study about the engineering drawings and manufacturing process for that, and actually that's your report. So what you're writing down is the task of the production engineer. You write down how to make the parts and how to make the final assembly. So you will suggest, okay, now we have the CNC milling machine, so we don't have the casting operation, so we can do the casting with another contractor, which can be a foundry. We select different materials depending on the availability and the cost. And then we are going to have the parts, the casted part, and we start to do the machining for it. So this is the cassette part, which is going to be this one. So the first operation is going to be the face milling for the solid face. Okay. So to make this one, we need to have a certain grade. The surface finishing for this one actually is going to be quite important, because we're going to have this seal between this surface and the cup surface, and we should prevent any leak under higher pressure. So the surface finishing for this one is going to be very important. This will be done on the milling machine. Depending on the time required to submit the 1,000 parts. Okay, or we are going to make 1,000 parts a week. So in that case, we will do the calculation. If we think that it's going to be worth it to buy the CNC center, machining center, then we can buy it. If not, just use the machine you have in your workshop. Okay, so this will be the first operation. Do the milling operation for the solid face. Important and critical dimensions, because we are going to have a leak possibility if this surface is not machined very well. Then we need to do the drilling and the threading for the threaded holes, where we're going to have the 6 stud. We're going to sit there to lock the 2 parts. Now the dowel face, we're going to have these dowels sitting on both sides. Why the dowels are going to be important?
Keeps the 2 valves aligned.
Exactly. So it's going to guide you about the correct position of the cap on the main body. Because actually wasting time on doing that, try to realign by yourself, this will be wasting time. And this time for the assembly process, even if it's going to be something about 10 seconds for each part, this will be accumulated time. So that's a part of the design for the assembly process, where you try to reduce the time for the assembly operation. The most important thing for this part, it should have a clearance fit. Clearance fit. So the dimension should be very important, because we would like to put the dowel by doing the press fit inside the hole. We're not going to take it out for one of the parts. It should be fit there, not moving. Now, how to achieve a clear fit dimension for the hole? You remember the steps for making a correct hole? We explained that in the drilling lecture. We do the drilling, we do the boring, enlarge it a little bit, then we do the reaming to have the exact dimension. So for example, if the diameter of this hole is going to be 10 millimeters exactly, because the diameter of the dowel we're going to put in is going to be 10 millimeters exactly. How to do that? We're going to drill a hole which is going to be with the dimension, let's say 9.5 millimeters. Then we're going to use the boring operation to enlarge it a little bit to make it 9.9. Then we're going to use the reaming to get the exact value of 9.99 millimeters or 10. We're going to have tolerances for that. It can be, for example, the acceptable dimension is going to be 10.01 and 9.999. And this to make the dowel sit exactly inside the hole. Now, the next operation is going to be do the cutting for the gear and the push both. Now, this operation, once again, can be done on the milling operation. But we still can take it out and do it on the boring operation. Now, why I said boring, I didn't say the drilling, because these will be an almost available holes, because we put the core when we did the casting operation. Okay, so we already have a holes. We're only going to enlarge it and make the good surface finishing for it. So this operation can be done by the boring operation, or it can be done also on the milling operation, depending on the accuracy or the dimension you would like to have. I think this one is repeated. Okay, so we're going to repeat that again. So we do the milling for the solid face. We drill and thread the holes. This can be done on the milling machine and also can be done on the drilling and threading machine, which is going to be a special one. And then we're going to drill and have the accuracy dimension at the clearance fit for the dowel holes. And then we're going to do the machining for the gear and the push boards. And this can be done once again by either do the turning operation, milling operation, or we can do it on the boring machine. And also we can do honing operation, by the way, because once again, we would like to have some lubricant to be in these holes, something similar to what we have in the car engine, because we are going to have the gears, which always going to have a contact with these walls, and we would like to have a continuous lubrication. Okay, so we go now to the other side. On the other side, we need to do the face milling operation for the both ports. Okay, on these surfaces, we're going to have the milling operation. Just simply do the mill cut, face milling cutting, and then we can do the threading operation for these holes. And the threading by this size can be done on the milling machine. So to write down these things, we can simply tabulate the thing. This part of the table actually is coming from something called the route sheet. On the route sheet, as a production engineer, you're going to write down the steps. What are the machine, which is the tool, the description, and you will give a recommendation for the cutting speed and some comments, for example, how to hold the part. So the operation number one is going to be the mill stud face. Okay, so I'm going to use the face milling cutting tool, do the face milling for the studded face. The tool we're going to use should be the face milling cutters, because this will be able to cut the flat surface with a good surface finishing. Then these are some examples for the cutting tool. You can use the same tool, for example, in your table. Okay, so the tool is going to be the 160 score 50.8, and the insert type is going to be the SEKN 1203. Okay. Now, for the grade type, you can have it actually from this table. This will give you, depending on the cutting tool, and what will be the ISO standard for the inserted grade. Okay, so we check the inserted grade. It's going to be the K20, and the cutting speed recommended for this type of the cutting tool with this material is going to be 120 meters per minute. And we give a name for the suggested supplier, that if the workshop doesn't have it, then they will be able to find it. The operation number two is going to be the drilling for the cap screw holes. Okay. By the way, this is the operation for the face milling operation. This is the video for it. Of course, more tools is going to be better for higher rate of the removal of the material. And we're going to achieve a new surface. Now, of course, the quality of the surface we're going to achieve will depend on the velocity and the feed rate, the rotation velocity and the feed rate. This considered going to be an acceptable dimension for the, surface roughness for the part. Okay, now, when we finish with the drilling and the threading, we can go to the fifth operation, which is going to be the rough hole bore for the gear and the push bores. So we can do the cut by using the normal cutting tool on the milling machine, but we can also have a custom cutting tool like the one we can see in this photo. So can you tell me how this custom cutting tool is working?
cut in a small diameter and a larger one.
Exactly. So it can cut in two different diameters at the same time. So one shot is going to do both cuts. So, and this will reduce the time for the machining, and try to use, for example, the 20 millimeter diameter cutting tool. Just keep doing rotation multiple times to achieve the final cut. So as you can see here, that the tool is a custom multi-bore and facing tool. So this one can do the facing for the lower side. At the same time, it's going to do the boring operation for the hole. Hey, Ricky, how are you?
Do you need any help?
Oh, no, we're going to finish in 10, 20 minutes.
Oh, really?
Yeah.
Okay, sweet. Are you meant to be here until 7 today?
Yes.
Meant to be, right?
Yeah. But we don't have just a theoretical thing.
Yeah, cool. No
We're
worries.
covering that, we're recording it,
no
and we're
worries.
going to distribute to the others.
Sweet. All right, I'll leave it to you then.
Thank you for coming.
Sorry.
Okay. So once again, we need to choose the different cutting tool inserts, and as you can see here, that we're going to use the TNMG types for the tungsten carbide, and the insert code is given as the KM 3015. Now, why the code is going to be very important, or the grade is going to be very important, because this will decide what will be the available cutting speed or the maximum cutting speed for this cutting tool. Okay, and the next operation is going to be, once again, the gear and the push-pull. So the first one was the rough cutting, and the second step, number 60, is going to be the finishing cut. So what you can see here is, this is the custom cutting tool. Okay, you can see this different one, but it's going to cut different levels from inside and outside at the same time. From inside and the outside at the same time. Okay, so one movement is going to finish the whole work without repeating the process. Okay, so you have the tables available for you for each operation. I advise you to make your own Excel sheet with the multiple steps and try to put everything there. Now, in this folder, I remember that I used to have the inspection process. What?
Can we use those tables for our major report?
Yeah, you can put these tables, because once again, the table.
Foundation. Being the first enterprise that developed a Skynet.
The table is going to help you to. It's better than writing a whole paragraph about the things. Just write down a table. And this once again is going to be a good exercise for you to be a production engineer. You're going to be in workshop one day, try to explain to the technician what to do and how to do it. Okay, now we're going to watch multiple videos before we're going to go, and this first video is going to be about the gear machining.
Process technology in Taiwan. We have always taken to improving technology and innovating equipment as our core concept. China Gear Industry Company Limited was founded in 1984. It has contributed to its customers for almost 30 years. Established in eastern Taichung City, it began with the development of middle and small gear. We expanded the facilities and strongly and healthily developed, and we are now involved in the manufacture of precise micro gear and have passed the ISO 9001 international quality attestations, this being the most important enterprise partner. Process techniques and process. Procurement of raw materials. Incoming raw materials must pass rules and relevant quality and safety standards and be certified by our QC department before further processing. Once the raw material passes the QC standards, it is then put through CNC machining to achieve pre-shaping. The entire process is done by auto-feed CNC equipment to ensure high productivity and precision finished products. Vernier height gauge. Run-out inspection machine, etc., are used to check the length and concentricity of the finished product. The purpose of knurling is to improve the shaft in the way of being firmly fixed on coiled silicon steel sheet. Quality control personnel then inspect the outside diameter. Advanced equipment imported from Europe and the US is our best auxiliary to achieve excellent quality standards and production efficiency. As an example, the Swiss-made grease powder P60 is used for rolling the motor gear shaft and sanding the shaft. A US-made Phoenix 125GH by Gleason is used for machining automotive gears. Chop Chop is also a pioneer in introducing the Coffer MZ130 for the hobby and sanding of micro gear, as well as the machining of the motor gear shaft, bevel gear, worm, and worm gear. Several Coffer 200s have been imported to meet the increased copying and sanding demands in gear and motor gear shafts. Chow Chow will keep pace with the market trend and customer demands in order to be the provider of choice. The sanding process is applied to gear and shaft to correct heat treatment-induced deviation, hence reducing noise while increasing lifetime. The tooth lead and tooth profile of the sanding process products are then inspected by a specialized inspection machine to ensure the quality of the finish.
So this will be inspection process you can talk about.
Gear lapping is a surface treatment of the gear and a common way to increase gear precision. GIS 0 or DIN 4 is attainable by this method. In addition to the state-of-the-art inspection equipment used to carry out computerized inspection of gear profile, gear lead, and pitch, QC personnel routinely sample the tangent length, groove diameter, topping, and outside diameter. We also provide heat treatments such as carburization, high-frequency hardening, and magnification to harden the surface. Heat-treated final products will then go through slice sampling and embedding inspection for the correctness of the hardened depth and stability. The precision tightening of the shaft will increase its roundness. And then a full inspection of our final products in terms of the output appearance and outside diameter. To further increase the product quality, automatic ultrasonic cleaner is used for cleaning and drying to prevent rust caused by residual moisture on the final product. It is then packaged to ensure the integrity of the product during shipment. Finally, the product is shipped to the customer designated location, accompanied by a complete shipping and inspection report. Product series.
I'll leave this part because this is just for the company itself. And I think that I have more important videos here. Gear manufacturing again. I think I have a video for the gear part number 3. I'm going to post this one as well later. Checking workload. No, we saw this one before. Okay, we saw this one before. Okay, so machine plug here, multi-pocket, multi-spindle. Okay, now this can be an example once again to make a multiple holes at the same time, and also, of course, going to be a multiple threading operation. This can be a suggested method if you would like to reduce the time of doing the drilling and the threading of the thread holes on the face. Okay, so now I think that we need to finalize this session by talking about the product itself. So that's my product, and of course the first part is going to be machining the shaft. This shaft definitely is going to be done on the turning machine. Then we're going to do the cutting of the gears by using one of the operations we just described in the video. When we finish with that, we're going to do the heat treatment and the grinding for the size, because this size are going to be two critical dimensions to avoid having any struggling in the rotational process. Reduce the friction by increase the surface finishing. Also, another critical position is going to be the gear surface. We need to do a good inspection for the gear teeth, otherwise we're going to have the hanging for the gears when they're going to start. The diameter of the gear is going to be another important dimension, because this may stop the gear from rotating inside the bore. We need to do the supplying. Usually the supply is going to be done on the milling machine as well, and also it can be done by the hopping operation, and you will have something like 2 to 3 different operations to make the supplying here. Now these holes, by the way, at both ends of the shaft, simply because we hold it on the turning machine, on the grinding machine. Okay, so we can do the grinding operation for both sides. That means this part was rotating between centers, and you can refer to the grinding operation lecture to remind you about what we're going to do. Now, once again, for this operation, we're going to have two faces, the face number 1 or side number 1 and side number 2. We need to do it either on 2 setups on the machine. For example, again, to put this face first, do all the operations starting from this point to the end. Then after we finish in the first cut, we take it out and we do the second one. In certain operations, certain circumstances, if you're going to have a twin spindle machine, turning machine, then simply we can do with one setup. Hold the part, do the first cut, then send it to the other spindle, do the second cut, and the part is ready. Put that as an alternative machining process, because you don't have the twin spindle all the time. When we finish with the shaft, we go to the main body. So in the main body is going to be done by the casting operation. When you finish the casting, you are going to do some basic tests for it. For example, you can simply just hammer it to know how brittle it is. We can do the compression test, we can check the vibration, everything to check the quality of the casting. And actually you can search online to find the different types of the testing for the casting quality. Through the casting, we are going to have the pre-holes, okay? And of course, this surface is going to be something similar to the surface we have here, which is going to be very rough surface. This face is too critical because we are going to have the gasket, and then we're going to add the cup, the cover. Okay. By the way, the operations to make the cup. Can you give me? Okay. So the operation to make the cup is going to be exactly the same operation to make the main body. This will be done by the casting. We're going to do the face milling, drilling. Here, the difference is going to have the slope cutting, which is another operation we have on the milling machine. So when we finish with the cleaning of the part and inspecting of the casted part, we start to put on the milling machine. On the milling machine, we're going to do the face milling, drilling, and threading for the 6 holes, the threaded holes. This can be done by using a machine similar. It's not actually not going to be a machine. Actually, the cutting head itself can be multiple spindles, which can do 6 drillings at the same time and 6 threading at the same time, and this will reduce the time of the machining. Also, we're going to have the dual holes, these 2 dual holes, and this will be a press fit part. So we have to take care about the dimensions of the holes here, the double holes. So to do this drilling, we have to do it in multiple steps. The first step is going to be drilling. For example, take it to 9.5 millimeter diameter. Then you do the boring, which is enlarging the diameter slightly. Then you are going to do the reaming operation, which is going to increase it at very specific diameters. It's going to remove very thin layer to have the exact diameter. Okay, so 3 steps we are going to do for the double holes: drilling, boring, and reaming. When we finish with that, we are going to go for the bores, and we're going to do it, as we mentioned once again, just put it on the milling machine and it can do the cutting for the holes, boring the things, and do the surface finishing. The same thing is going to be for the bearings holes at the end. But we said we can, because we are going to make many parts of that, to reduce the time, we can have the custom cutting tool, which can have multiple levels. This custom cutting tool can do the boring and the facing operation for the lower face there in single shot. But in all the cases, we would like to remove the material at higher rate at the beginning, which can be the rough cutting. Then we're going to repeat the operation with a little larger cutting tool to have the finishing operation. The main difference is going to be with the feed rate speed and the rotation speed. When we finish with this side, it's ready to be used. We turn to the other side. We're going to do the face milling for both parts. Then we're going to do the threading operation, and this operation can be done on the milling machine. Now, during that, you can put the remarks on how to hold the parts, how to hold such block on the milling machine. What do you suggest? Now, the first position is going to be like that. We would like to hold it and do all the operation there. It's going to be by using the vise. The vise is something similar to that. It's going to be sitting on the machine. So the vise will hold it from both sides. We're going to do the cutting operation. Then we can simply flip it to the other side and repeat the same thing. Put it on the vise and do the milling operation, and the part is okay. The same thing will repeat for the cup. For the other parts, for example, these parts, we can machine them from bars, but I think that because the diameter is standard, so you can buy the double side threaded shaft from the market. It should be available for other operations. All the bolts and the nuts, the seals can be bought out of the shop. Now, for the Frosty Plate, for each pump we are going to have 2 Frosty Plate, and this Frosty Plate is going to be done by the die casting operation for the massive production. It's made of the aluminium. Some of them, this one doesn't have, but the other one does have some cavities, as you can see. Okay, and this actually to recirculating the oil during the operation. How to make the bearings was going to be actually pushes with Teflon inside. Actually, this should be done by a specific operation. I mean the coating operation. We talked about the coating operation in the surface treatment operations in the manufacturing. So this should be done by an external contractor, but mainly we're going to have the rolling operation to make the parts a cylindrical plate, and seam welding on the side. Now we need to coat it with the Teflon, and it's going to be gutted and going to be ready to use. These parts, how the bearing is going to be sit inside the holes, something is going to be by the press fitting as well. What else do we need to do? The critical points, once again, is going to be dual holes, the duals themselves, the surface finishing of the face, surface finishing of the gear holes. What else? Yeah, the face we have for the gear room and for the bearing sides. So this will be critical points beside the dimensions of the gear shaft itself. The supply, the surface finishing of the shaft, and the gear teeth finishing and dimensions are going to be a very critical points for the to be manufactured. Okay, so I think that we covered everything. And if you have any question, go ahead. I don't know who we have on the meeting.
With the reflection for the Untitled project,
Yep.
do you put them as part of your report, or do you submit them individually
No, just put it at the report at the end.
at the end?
Yep. So student number 1, your name, your student number. This is my reflection. Student number 2, the student number and name, my reflection. Yeah.
And with the submission, right? Do we all submit the same?
Oh,
video?
that's a good question. Whoever asked me, I asked them to check with this subject coordinator. I mentioned that in the lecture actually. Check with the subject coordinator because I never use the group submission for the Turnitin. Because usually if you do it on UTS online, the group members should be joining the group and one submission will be go for all the students. But I don't have that with Turnitin. So check with this other coordinator or just remind me tonight to check with him and again to send you an email tomorrow about how to do it. Or maybe he's going to do it.
You got an email about us, so you said the team leader submitted. You got an email about it, and the team leader said submitted.
Oh, it's the.
They said that?
Yeah.
They said the team leader should submit? Okay.
It's on the email.
Okay. So anyway, for the last thing, before you just hold your submission till tonight. I know I did that before. I show you an example for a good report. I'm going to make another one today because I don't remember where I put the other video. So I'm going to make one today. I'm going to show 2 reports from the previous 2 semesters with the one who got the maximum marks. Because the student asked me about the calculation part. I haven't seen any calculation part in any reports. I haven't seen the standard for manufacturing of the pump in any of the reports. So anyway, we're going to cover 2 of them and again send you the video at the end. We're going to finish that. So are you ready to submit tomorrow?
Yeah.
Okay. Oh, be careful. I think that the UTS online is going to be available on Sunday.
Not gonna be.
Yeah, I think there's a message on UTS online. Says it's not available on Sunday night or Sunday. I'm not sure exactly. So try not to make a late submission. Just try to make it on time. We'll check that now. UTS online. Where's UTS online? Okay. Yep, so it's not going to be available between 7 a.m. till 7 a.m. Oh, till 7:30. It's all in 30 minutes anyway. You don't have to worry about that. Okay, done. So, okay, guys, online, do you have any questions about the major project or the hand pump project? Okay, so we are going to end the recording now, and I'm going to upload the video